Hello everyone, in this video we will be solving problem 2943, maximize area of square hole in grid. The problem statement is, we are given an m by n grid with h bars and v bars as removable bars in it. The aim is to calculate the maximum square hole in the grid that we can make by removing the bars in it. In example number 1, the values of n and m are 2 and 1 respectively, so the corresponding grid will be add 2 to each of them. That gives us the grid of size 4 and 3. We have two bars which can be removed horizontally at position 2 and 3, which I have highlighted in red arrows, and one vertical bar at position 2. One possible combination is to remove the horizontal bar at position 2 and vertical bar at position 2. That gives us a square of side 2, giving us the area of 4. There is one more possibility where we can remove the horizontal bar at position 3 and the vertical bar at position 2, which will give us a slightly different variation of a square, but the total is still the same. I hope this example was helpful. Let's switch to whiteboard and discuss possible solutions. Let's use this example where m and n are 3 and 5, and the first vertical row highlighted in red is removable. I'll extend the example to also say that the horizontal bar at position 6 is removable, and so is the horizontal bar at position 2. As you can make out, after removing those columns and rows, we have two square holes of size 2 each. If we assume that one more column at position 3 is removable, after removing that bar, you can see we can build a bigger rectangle but not a square. And this change is impactful to both the squares that we have built earlier, the first one at the top and the other one at the bottom. Now if we had one more horizontal row at position 3 that is removable, we could have built a bigger square of size 3 at the top. As the area of the square is going to be 9, which is side square and greater than the previous calculated value, that will become our output. With this example, I hope you are able to identify the pattern. All we need to do is identify the rows and columns which are removable but consecutive to each other or next to each other. Only then we can build a bigger square. In this example, because the vertical rows were at position 2 and 3 which are next to each other, and same applies on the horizontal rows as the two rows were 2 and 3 next to each other or consecutive, we were able to build a bigger square. If they were not consecutive to each other, then we would not be able to build the streak or the longer side, giving us a better results. At a high level, in our implementation, we'll start by iterating through all of the vertical and the horizontal bars to identify how many items are consecutive. Once we know the maximum streaks of consecutive numbers for both horizontal and vertical, we'll compare it with each other. Comparison is needed because we are trying to build a square. So the smaller number between the two rows and columns will become the side of the square. The time complexity of this solution is going to be O of h log h plus v log v, because we need to first sort the input arrays for vertical and the horizontal bars to identify how many consecutive numbers are there. While the space complexity will be O of 1, that is constant space, as we'll be doing in-place sorting. I hope this explanation was helpful. Let's walk through its Python implementation. In this Python implementation, I've created this helper method longest consecutive, which accepts the integer array as the input. Inside this method, I have a small validation to make sure that the bars is not empty. If yes, then I'm returning 0 as the output. The next step is to sort the input array into ascending order. The next step is to start a for loop to iterate through all of the elements in the given bars array. If the difference between value at I and I minus 1 is 1, it means it is consecutive, so we increment the current streak pointer by 1. And on the next line, I'm using the max operation to save the higher value between the max streak and the current streak into the max streak variable. If the difference is greater than 1, then we need to reset the current streak to 1 and continue the loop. To handle an edge case where there could be a duplicate values in the array, I have added an else condition to just do nothing and let the current streak continue. Within the main method, I am calling the longest consecutive helper method twice, once for horizontal bars and the other time for the vertical bars. The output is then compared with each other to get the minimum value, as that will become the side of the square, and I am returning the square of that value as the output. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and nearly 11% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.